The laws of motion. Let's talk about forces and the concept of a force. Force can refer to the interaction between two objects. The interaction of two objects can cause a change in velocity. For example, when you kick a ball, the ball interacts with your foot the moment it is in contact with it. So in that case, the two objects that are interacting are your foot and the ball. And in that case, you can say that there is a force between your foot and the ball. Another example is pushing a book away from a table. So when you push a book, the interaction is between the book and the table. The moment that your hand comes in contact with the book, that force appears between your book and the hand. In both examples, the velocity of at least one object changes. In kicking the ball, the velocity of the ball change, perhaps from being zero velocity, being stationary on the ground, to having an initial velocity at a certain angle above the horizontal, causing the ball to fly out in a trajectory, projectile motion. But forces do not always cause changes in motion. For example, when you sit down, you are actually interacting with the chair, but not only that, you are interacting with the earth. The earth pulls on us with the force of gravity. It is a kind of force that is known as like action at a distance force, because you don't need to be in contact with the earth to be interacting with it. Even so, you remain stationary. For example, you push a large boulder, and in that moment, your hands interact with the boulder, but the boulder does not move. Now let's think about the moon. What force causes the moon to orbit the Earth? According to Isaac Newton, forces are what causes any change in velocity of the orbit. If you look at the moon always has a constant change in velocity as it orbits the Earth. Its direction always changes. Therefore, actually, the force that causes the moon to orbit the Earth is its interaction with the Earth. The moon and the Earth interact, and this interaction or force is known as the gravitational force. There seems to be two kinds of forces, the contact forces and the field forces, or the action at a distance forces. If you look at this slide, the contact forces are on top. When a coiled spring is pulled, the spring stretches. And in this case, your hand is in contact with the spring is in contact with the earth. When you pull a stationary cart, the cart moves. A change in velocity of the cart. Your hand is in contact with the cart. When you kick a football, what happens to the football? It gets deformed and it gets set in motion. Your foot is in contact with the football. Field forces do not require contact, and there is still an interaction between the two objects. For example, gravitational force of attraction between two objects in mass. For example, all the planets, including the Earth, are in orbit around the Sun because of the interaction between the Sun and all the other planets. This is called still the gravitational force. Because the Sun has mass, the Earth has mass, that's enough to cause an interaction. In fact, any object that has mass interacts with all other objects that have mass. The electric force, which is the interaction between two objects that have non-zero electric charge. Negative charge, in this example, and a positive charged object, they interact by attracting towards each other because they have opposite signs. And no contact is required. Magnetism. Force bar magnets exert a piece of iron. Again, there's no contact involved. Actually, the difference between a contact force and a field force is not that sharp. At the atomic level, all forces are classified as contact forces. Anyway, there are actually 4 fundamental forces in nature. It seems that there are many ways things can interact with each other, but we can all of them are either versions of or magnifications of one of these 4 fundamental forces. The first is the gravitational force between objects with mass. Second is the electromagnetic force between electric charges. Third is the strong force between subatomic particles. And 4 is the weak force that arise in certain radioactive decay processes. In our studies in classical physics, we're only concerned with gravitational and electromagnetic forces. So, how do we measure force? There are many ways, but one common way is to use the deformation of springs to measure the force. As you can see here, imagine that you are hanging an object on the spring. The vertical force applied to the spring scale causes the spring to elongate, and then the elongation will cause the pointer to go through all these various numbers on the scale and help us determine what force was applied by the object that was hung on the scale. So, force is actually a vector. So if you look at these symbols, you will realize that we are doing components, getting the components of the force. If we know the angle below or above the horizontal, in this case below, we can get both the x component and the y component of the force, and we can get the magnitude of the force, which you can see here is represented as the absolute value of F, and F1 squared plus F2 squared. So when we deal with forces, we must use the rules of vector addition to obtain the net force on an object. So sometimes there are more than one force acting on an object. So in that case, we have to consider all of these forces and add them using vector addition to get the net force or the resultant force in order to know what the overall effect is on the object. So that's the end of our discussion. I just introduced you to the concept of force. Remember that force is an interaction between two objects, and that force is a vector. Goodbye.